All right, let's dive right in. Today, we're going to tackle a question that sounds, well, almost impossible. How in the world do you build something absolutely massive in the middle of the ocean?
Just think about that for a second. Pouring concrete needs to be done in a dry, stable place. And the bottom of the ocean is pretty much the exact opposite of that. So how do they pull it off? Well, the answer is one of the most clever tricks in all of civil engineering, and it starts by facing down a truly incredible challenge.
You know, before a bridge can even dream of stretching across an ocean, it needs legs. Really strong legs. But we're not just building on solid ground here. These foundations have to be anchored deep into the seabed, all while getting hammered by the relentless forces of the open water. This isn't just hard. It feels like it should be impossible.
So let's really break down what engineers are up against. You've got constant, crushing water pressure from every direction. The seabed itself, it's often just soft, mushy, unstable soil. On top of that, you have tides and currents that are always trying to wash everything away. And like we said, you just can't pour good, strong concrete directly into the water. So, with all of that working against you, how do you build a foundation that can hold up thousands and thousands of tons?
Well, the very first step is to just bypass all that soft, unreliable seabed stuff completely. The real goal here is to drill way down to create these incredibly strong pillars, or piles, that are anchored directly into solid bedrock, far below the ocean floor. That's going to be the real foundation for the entire project.
To get a job like this done, you need some seriously specialized tools. First up is something called a viro hammer. Now this thing doesn't just pound, it vibrates like crazy, basically liquefying the soil around a big hollow steel pipe and letting it sink right through all those soft layers. But once it hits hard rock, a totally different beast takes over, the cluster hammer. This thing is a massive drill that both spins and hammers at the same time, just pulverizing solid rock to keep digging deeper.
Okay, so let's walk through it. First, they drive that steel casing down. Second, the big drill gets to work pulverizing the rock. Third, you've got to get all that pulverized rock junk out of there, right? So they blast compressed air down the hole, which forces all the debris up and out. Now you've got a nice, clean, deep hole. So, a steel reinforcement cage gets lowered in, and finally, the concrete is poured using a special technique to make sure there are no air bubbles. You do this over and over, and eventually, you've got your anchors.
So the anchor points are in place, but you still have a huge problem. You can't actually work down there. It's still the bottom of the ocean. So now, it's time to introduce the main event, the piece of tech that makes everything else possible. Meet the caisson.
So what is a caisson, or caisson as it's also called? Well, you can think of it as a giant, bottomless steel box. It's basically a portable, private piece of dry land. It gets lowered down over those piles we just made, and its job is simple but absolutely game-changing. Create a dry, protected room right there on the ocean floor.
But wait, here comes the next big problem. Even with this giant steel shield in place, you're still at the bottom of the ocean, and all of that immense water pressure is trying with all its might to force its way into any little gap it can find, especially where the caisson meets those concrete piles.
Right? This is the million-dollar question. You've got this massive structure, but the spots where it slides over the piles are a huge weak point. How on earth do you create a perfect seal against the crushing force of the entire ocean?
Well, the solution is just genius because it's so elegantly simple. Step one, they don't try to stop the leaks. In fact, they expect them. They know water's going to get in. So, step two, they trap it. The engineers build these clever pipes that go up and around the inside of those leaky joints. And here's the brilliant part. Any water that leaks in gets caught and held inside these pipes, which leaves the main workspace in the middle completely, totally bone dry. Problem solved.
So now, with a safe, dry place finally established, the real work of building that massive foundation can finally get underway. A full-on construction site now exists where there was once just open water.
You have to imagine, inside that caisson, it's a completely different world. The workers have a solid, stable platform. They can assemble all the complex steel rebar cages they need, and they can pour concrete in a perfectly controlled, dry environment. There are no tides, no currents, just the business of construction. This means they can guarantee the highest quality and strength, all while the ocean is raging just inches away, on the other side of those steel walls.
So once that massive concrete foundation has been poured and has hardened into one solid block, the caisson's job is finally done. It's time for this temporary steel shield to go away and reveal the permanent structure that it helped create.
And this is the moment it has all been for. That huge steel caisson is carefully lifted away, and what's left behind is a perfect, solid concrete foundation, now a permanent part of the seabed, totally ready to support the massive bridge tower that's coming next.
When you really think about what's happened here, the engineers have basically created a permanent piece of land where there was none before. For all intents and purposes, they have literally pushed the ocean aside just so they could build.
So the next time you see one of those incredible bridges stretching across a huge body of water, just remember what's happening below the surface. It's not just sitting there. It is anchored deep into the earth through this incredible process, built on a temporary patch of dry land by engineers who figured out the secret to building on the abyss.